Hey students, this is Mr. Ng going over question number 1. Select the expression as equivalent to m squared minus 25. I recognize this is the power of 2, so this is a quadratic. And if I add a 0m here, now I have a trinomial. Now if you forget those, the standard form for trinomials looks like this. And then you have an a value that's 1, b is 0, and c that's negative 25. And if you look at what they're trying to do here, they're trying to factor. So I teach my students to factor by using Xbox method. My two numbers, a times c is negative 25. My b value is 0. I need two numbers that their products is negative 25, and those same two numbers, their sum is 0. So those two numbers are going to be 5 and negative 5. If I take those two numbers and I put them into my m's here, m plus 5 and m minus 5. Remember, the order doesn't matter here for multiplication, so your answer is going to be C. The reason why B is incorrect, this would actually be m plus 5, m plus 5. And remember, you can always check your answer by using FOIL or the box method. This one is just m minus 5, m minus 5. There's two of them. They put them together. That would be incorrect. And if you actually multiply those out, that would be the same one as this one up here. So use some kind of method. Some teachers use guess and check. I use Xbox method. And then again, you can always just use FOIL to check your answer to get m squared minus 25. Hey, math lovers. Question number 2, select an expression that is equivalent to the square root of 3 to the 8th power. An expression has no equal sign, so there's no equal sign, and is equivalent. We're just looking for something that is equal to this. So they're saying, is the square root of 3 to the 8th power equal to this one, this one, this one, or this one? Good thing is we know that one of these are our answers. So I'm going to write this a little bit larger. Here is my base for my exponent, and my exponent here is 8. Now, square roots or radicals, the default number, meaning the number that's always there, that's imaginary. It's not a 0, it's not a 1, it's a 2. So this expression now is equivalent to the 8 is going to go in the numerator, and the 2, or this index, what it's called, goes in the denominator. So now we have this radical expression, which is equivalent to a fractional exponent. And then 8 divided by 2 is 4. So 3 to the 4th power is the correct answer. It is C. A would have been wrong if you are trying to simplify if you switch those up. So it would not be this. It's not 3 to the 2nd power and the index is 8. That would have been wrong. And I don't know how they got those. So not B or D. So the correct answer is C. All right, question number 3 says, enter an expression equivalent to all of this using the fewest number of possible terms. Okay. Enter an expression. This has no equal sign. That's why it's called an expression. Equivalent means equals to. And then it says using the fewest number of possible terms. So this is a term, 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 this is a term. I think they're just really telling us to do something like combining like terms. Combining like terms. Notice the ones I put in boxes here. Before I do that, I'm going to use PEMDAS. PEMDAS to simplify. And I'm going to see if I can do anything in the parentheses first, which there's no like terms. And then I'm going to do the exponents. There are no exponents. These are exponents, but the next thing I'm going to do is the multiplication here of this negative sign. So I like to think of it as a negative 1, and I'm going to go ahead and distribute that. So I have 3x squared plus 2y squared minus 3x, and I'm going to drop the parentheses. Well, we don't really need this. 2x squared plus y squared minus 2x minus x squared minus 3y squared minus x. And I don't need that parentheses there. So now I'm going to look for the ones that are like terms. I'm going to put a box here around those that have anything with an x squared in it. So here's another x squared. This one has y squared. No, no, yes. And that's not part of the problem. Okay? And if I put a 1 here, then I'm just looking at the coefficients. That's the number in front. So 3 plus 2 is 5. 5 minus 1 is 4, so I'm going to have 4x squared. Okay, now I'm going to do a different shape, but I'm going to do anything with the y squared. So these are like terms. Like terms. Like terms. And like terms. So all my triangles there have like terms. And if you don't have a number in front, again, that number is 1. The leading coefficient is 1. So 2 plus 1 is 3. 3 minus 3 is 0. So I have 0y squared. And then I'm going to do circles for the last one. You can use any of your favorite shapes. They all have just an x. And this one doesn't have a number, so I'm going to put a 1 there. So I have negative 3 minus 2 is negative 5. Negative 5 minus 1 is negative 6. I have negative 6x. Now, we know that anything 0 times anything is 0, so essentially we don't have to write this. So what you're going to type in is 4x squared minus 6x. Now, if this was on a computer and I'm going to type out these expressions, I'm probably going to type in something like this. I'm going to press the button 4, and then you can choose XX is my shortcut. You don't have to do the exponent. And then the minus sign. And then I have 6. And then I have x. So then here's what you would type in as your fewest number of possible terms. You only have 2 terms, 1, 2. Question number 4. When a transversal intersects a pair of parallel lines, so here is my parallel lines, and the transversal is like my pen, it's cutting those 2 lines, it will create 2 pairs of alternate exterior angles. Ricky, I don't know who Ricky is, but Ricky claims that the angles within each pair are congruent. That means the same to each other, but not congruent to either angle in other pairs. So part A, draw a transversal through the point that supports Ricky's claim, or select none if there is not a situation. So he's saying that within each pair are congruent. So I need to draw one that supports his claim. So if I draw a line this way, this is my transversal. Ricky claims within each pair are congruent to each other. So you have the corresponding angles. Let's number those. 1, 2, 3, 4, 5, 6, 7, 8. 1 and 3 are corresponding. Those are congruent. 1 and 7 are vertical angles. 3 and 5 are vertical angles. Those are congruent. But not congruent to either angle in the other pair. So this is the other pair. These are not congruent. Okay. So part B says, draw a transversal through a point that refutes Ricky's claim. Well, we're saying that these are not equal. How would I actually get those equal is if I draw this line down here, and if these are all right angles, they're all 90 degrees, these are called perpendicular lines, and if these are all perpendicular lines, this refutes Ricky's, because Ricky's saying that, for example, if I number the same numbers here, 1 and 8, he says, are not congruent to either angle in other pairs. But these are congruent because they're both 90 because they are perpendicular. So this would refute Ricky's claim. So I'm not going to select none for either of these. I couldn't actually draw that. So parallel lines cut by transversals, and this one supports Ricky's claim, and this one is a refuting or a counterexample to what he's thinking. Alright, here we have question number 6. Which inequality represents all possible solutions of negative 6 and less than negative 12? We recognize that we have to get n by itself here, so This is multiplication. I'm going to do the opposite or inverse. I'm going to divide both sides by -6. This gives me n, and -12 divided by -6 is 2. And then we have to actually flip the inequality sign. So whenever you multiply or divide by a negative number, flip the inequality sign. And then the answer is B. The reason why you have to do that is if you just divide by 6 on both sides, let me show you a different way. If you divide by just 6, you have the opposite of n is smaller than -2. And then you're just thinking of opposite numbers. So this one is basically telling us 2 numbers that are greater than 2. So that means you're saying you could pick any number such as like 3 or 4 to get a solution. So let's just say I pick -1. Opposite of -1 is +1. Is 1 smaller than -2? That would be false. So -1 is not a solution. We already know that 3 is a solution. If you pick 3 here, opposite of 3 is -3. It's -3 smaller than -2, and that's true. So this number line, giving yourself a visual, this idea of flipping the inequality is a little bit of a shortcut, but you can see how you can actually check your solution by just substituting in numbers. All right, here's question number 6. Question number 6 says, consider this right triangle. Enter the ratio equivalent to sine, not sin. It is sin to say sin, but sine of b. So I'm going to circle b here. And this is my starting point. Let's label the sides. Across the 90-degree angle is the largest side, which is called the hypotenuse. Largest angle produces the largest side. Going across the b, they call this, going across is the opposite side. So this is the hypotenuse, and this is called the opposite side. And then the last side is called the adjacent side. Adjacent means next to this angle. So you have this silly trig ratio phrase, so, ka, toa. And here's a cool thing about SOHCAHTOA. I need to figure out sine. Sine is this one, not these two. So I need the opposite over the hypotenuse. So you're not using the adjacent. That's only for cosine and tangent. So I have the sine of b is equal to opposite over the hypotenuse, which would be opposite over the hypotenuse, 21 over 29. And then on your calculator part, you can either choose, my calculator buttons can be 21 divided by 29, or just in case that comes out a little bit funny, you can also put parentheses around those, super helpful, or you can use this button right here, and then you just type in 21 over 29, and that should be your correct answer. Alright, this is question number 7. Cheryl, she's my mom's name, claims that any irrational number, think of it as a teacher who keeps talking on and on and on and on. They sound very irrational. And a rational person is has an ending, yes or no. So part A, drag a irrational number into the first response box, and when you square the results into a rational number. So they want us to square it. They want us to basically square each of these results and then figure out what happens. So let me do each one of these one at a time, and then you'll see which ones are going to go under part A and which ones are going to be under part B. Just zoom in here a second. Alright, so this is the first problem. And what I'm going to do here is just going to square the numerator and denominator. So let's do that. Now remember back to our fractional exponents, this is 2 to the first, and this is the denominator, so 2 to the 1/3 power squared, and this one down here is the square root of 3 squared. So that's the first power, that's a 2, so the square root of 3 is the same thing as 1/2. And what I'm going to do here is square it. And all you do is just multiply that. So 2 over 1, so 2 times 1/3 gives you 2 2/3. And over here, you're going to get over 3. The point is that you don't have a calculator, so this essentially turns into 2 squared, which is 4, and the denominator is an index. There are no 3 identical numbers that multiply to equal 4. It's going to be a decimal. So essentially what you're going to have is the irrational divided by 3, which means you're still going to have the irrational. So the first one is irrational. The first one is going to be irrational. Okay. Number 2. I have the square root of 3 over the square root of 2. And again, we're supposed to square both these results. Let's do that. And you'll realize that they cancel because the index and the exponent outside are the same. Let me show you why they cancel. Remember, this is a 2, and this is a 1. So what happens there is that becomes 3 to the 1/2 power. The square root is essentially 1/2. And we're going to multiply that by 2. And if you do the same thing over here, 2 to the first power squared gives me 2 to the 1/2. So 2 times 1/2, you multiply across, you get 2 over 2, which is just 1. So you get 3 over 2 is your answer. And that results into 1.5. And 1.5 is a rational number. So number 2 is rational. Let's do this next one. Number 3. So that's 2 to the first power, and we're supposed to square that again. So 2 to the 1/3 squared. You're just going to multiply there, and you'll get 2 to the 2/3. And we already saw, I believe that was above, that that's going to become irrational. Again, if you have the calculator ability on the SBAC, you can type in this, right? The cube root of 2, and then square that result. And if it becomes a repeating number, a decimal that keeps repeating, a non-repeating decimal, then it's irrational. So this is a irrational. So number 3 is irrational. Number 4, the square root of 2, and we're going to square that. Again, those who cancel the answer I already know is 2, right? These will cancel. But if you don't know that, just when in doubt, write it out. So square root of 2 times square root of 2. Don't have to make it super fancy. That's the square root of 4, which is 2. And that is a rational number. Number 5, pi. Okay, so pi is approximately 3.14, but it's a billion decimal places. It does not end. It keeps going on and on and on forever, so it's already irrational. So if you square this, you're squaring an irrational number, which basically means it's still going to get an irrational number. If you put that into your calculator, you'll see that. So number 5 is irrational. Again, if you just typed in pi squared into your calculator, it will go on forever. And number 6, the square root of pi. And again, if you square that, you'll get 2 of those. And really, again, that's 2 to the first, 1/2 times pi to the 1/2. And if you're multiplying the same base, you add the exponent. So 1/2 plus 1/2 gives you pi. And pi is already irrational to start with because it's a repeating number, but there's not an ending or a terminating, they call it terminating decimal. So this is still irrational. So the answers for this question, which when you put in here are going to be a rational number, that is choice number 2, and choice number 4. That means numbers 1, 3, 5, and 6 are all irrational. Alright, question number 8. A train travels 250 miles, so at a constant speed. So when I look at this, I think this is like total distance, right? My kids are going to tell me how long is the trip. And usually it's either going to be distance or time. So I have 250 miles at a constant speed, which we don't know how fast you're going, but it tells us in miles per hour. This is a distance over time, which is measured in hours. So our distance is miles, our time is measured in hours, and this is what speed is. You can see that constant speed is basically distance over time. Enter an equation that can be used to find the speed of the train. So I have to figure out the distance and time if the time to travel is, so right there it tells us time is 250. T equals 250, or time. And then hours is our, take that back, our distance is 250 miles. And the units kind of help us that I should have put it up there, right? 250 is my distance. And then time is measured in hours. So if I divide this, I can get 5 goes into 25 5 times, and 5 goes into 0. So that means I'm going 50 miles per 1 hour. Or we could say 50 miles per an hour. So in here, you can actually type in 2 answers. You can type in 250, parentheses 250, close parentheses divided by 5, or we can also do 50. You can just type in 50 as your answer. And either of those would be the correct answer. Alright, let's go over question number 9. Click above the numbers. So these are the numbers we're talking about. Click above them to create a line plot. A line plot is just a graph, or I'm also thinking this is a dot plot, for the given % chances of rain in different cities. So when you get this, if you can, I put a little check above it, or if you can annotate above it, just put a little check. So 65, 65, 70, 70, 80, 80, 80, 80, so 4 80s, 1, 2, 3, 4, 85, 95, 3 of those, and 100. So here is our line plot, or I call it a dot plot. We also call this trimodal because you have kind of 3 areas, 3 sets of buildings, 1, 2, and 3. And so this is our line plot. The formula for the rate at which water is flowing is R for rate, it's probably going to tell us that, R is rate, equals V over T, where R is the rate, let's write that, R is the rate, try to make that bolder, V is the volume of water measured in gallons, and then T, lowercase t here, is the amount of time, but measured in seconds. So select an appropriate measurement unit for the rate. What is this measured in? So if you kind of ignore volume, you can say, oh, I drink a lot of Slurpees on July 7-Eleven. You go to 7-Eleven and get free Slurpees. Did you know that? So go there. And you might say, hey, I could boast of how much Slurpees. And you might ask, how much can you drink? And you can say, I can measure it in gallons. I can drink a gallon in maybe like 10 seconds. So the unit for the rate would be gallons over seconds, and that would be choice B. And B is your correct answer. Alright, Emily is solving the equation 2 times x plus 9 equals 4 times x plus 7 plus 2. Her steps are shown. two parts, part A, part B. Click on the first step in which Emily made an error. So the first thing, if I'm doing this problem, I'm probably going to distribute there. 2x plus 18. And then I'm going to go ahead and distribute 4x plus 28. And then these are plus 2. So this step looks good. And then from this step, I'm then looking for like terms. These are not like terms. I'm not going to say 20x. That would be wrong. Looking over here, these two are correct. If I add those two together, that should be 30. So the next line, this one should be, this is fine. This step is wrong because it's not 26. This should be 30. So step 3 is the wrong one. Click on the first step. I'm clicking on step 3 because that's the error. Part B, click on the solution to Emily's original equation. So if I finish this problem, 2x plus 18 equals 4x plus 30. And I just need to solve that. You can go ahead and subtract 2x from both sides. I get 18 equals 2x plus 30. And then if I subtract 30, I get negative 12 equals 2x. And then divided by 2, I'm going to get x equals negative 6. And that would be choice in part B. This is the solution to Emily's original equation. If we did it correctly, would be negative 6. Alright, question number 12. A store sells used and new video games. New video games cost more than used games. Yes, that is true in stores. All used games cost the same, and all new video games also cost the same. Oh, that's a good place to go to. Omar spent a total of $84 on, or equals to, 4 used games. So I'm going to write 4, and then my variable u, what do you think that stands for? That is used video games. And 2 new video games. So plus 2, and then that's n. Sally spent $78 equals 6 used video games, 6u plus 1n. So this is Omar's, this is Sally's, and Janet. Janet has $120. It's kind of weird. Goes on to the next sentence. Enter the number of video games Janet can purchase after she purchases 3 new games. So 3n plus, I'm not sure how many used video games she can get. And if you look at this problem, you have linear systems of equations. You have 2 variables, n for new games, and u for used games. I'm going to use these 2 equations. We're going to solve them, and then we're going to figure out how much Janet can spend on used games. So let's write the 2 numbers right above it. Okay, so you can solve systems in multiple ways. You could use substitution, totally works. I'm going to choose elimination. I'm going to multiply the second equation by negative 2. If I multiply by negative 2 for this equation, I'm going to get 84 equals 4u plus 2n. And then I'm going to distribute this negative 2 to every single one of these terms. So I'm going to get negative 156 equals negative 12u, and then negative 2n. And then here, if I just add these 2 equations together, you'll notice that it eliminates one of my variables. It's eliminating my n variables. So if I add those together, 156 minus 84, I'm going to get 72. So negative 72 equals negative 8u. If I divide both sides by negative 8, I'm going to get u equals positive 9. One used game cost $9. So these, now you could pick any of these equations to work with. We know that a used game costs $9. I want to figure out how much a new game costs. You could pick any equation you want. I'm going to choose the one that says 78, just because the number for the new game is going to be so this right here is going to cost $9. 6 times 9 is 54. And if I subtract 54 from both sides, I'm going to get 24. One new game cost $24. Okay, so now we can go back to Janet's. Let's go to Janet's. 120, 3N plus, not sure how much used games she can buy. So if a used game costs 9, I'm going to put a 9 here. And an N value gets 24. So I have 120 equals 3 times 24 plus $9 for a new game, for a used game. So 120 equals 3 times 24 gives me 72. And I will subtract 72 from both sides. And I will get 48 equals 9 times the question mark. Okay, here's the question. I want to know how many used games, what's her name, Janet can buy. And so if I divide by 9 here, the number of games that can be bought is 5 times, because 5 times 9 is 45, and 48 minus 45 is a remainder of $3. So that means the answer is we can buy 5. 5 is your answer. So systems equations, a lot of work, but that's our answer. Good luck. All right. Click on the region of the graph that contains the solution set of systems of the linear inequality. So let's go ahead and graph this first one here. This one's nice because it's in slope-intercept form. So let's figure out which one of these two graphs it is. I have a y-intercept of positive 3. It has a slope of negative 1 over 2. So that means a down 1, right 2. Down 1, right 2. So I don't have a ruler. Let's see if I can create one right there. Let's double check this one. Y is greater than 2x minus 2. So I'm going to highlight this in red. I'm going to go down to a y-intercept of negative 2. Has a slope that's positive, so going from left to right, it's going up. Previous one going left to right has going down, negative. So this would be a rise of 2 over 1. So up 2, 1, right 2, up 2, right 1, up 2, right 1. So this is the right one here. Okay, the question is, where is the shaded region? So let's do the green one first. And what I'm going to do is I'm going to test 0, 0. If 0, 0 is true, then I'm going to shade on this side. And if 0, 0 is false, that means the other side is true, then you would shade that region. Okay? So let's do y less or equal negative 1/2 x plus 3. So I'm just going to test 0, 0. So I'm going to put in 0 for x and 0 for y. This becomes 0 and 0 plus 3. So question is 0. smaller than or less than or equal to 3. That is true. So for these, on the green line, 0, 0, and everything on this side is going to be true. So I'm going to go ahead and shade that in. Okay, for the red region now, I'm going to test the same thing. And you can only use 0, 0 if it's not going through the origin. So 0, 0 is not going through the origin. So for the red, if 0, 0 is true, then everything over here will be shaded. If it's false, then everything on this side will be shaded. So let's put in 0, 0 to the red one now. This will become 0 and negative 2. 0 is bigger than negative 2. That is true. So the 0, 0 side is true. So I'm going to shade everything where on the red side where it has 0, 0. All of that's going to be true. So let me go ahead and shade that. Okay, let me show you visually what is happening here. For the red equation, these are all your solutions in the red. For the green one, your solution's all over down here. And the only one that actually has both of them is this region right here, and this is your correct answer. So you would actually click on that region there, because it means it's a solution for both the red and the green. All right, let's go over question number 14. Use a circle to answer the question. The circle is centered at point C, line segment PQ, and is parallel to SR. PQ, SR, and then the parallel line marks. What is the measure of QPS? They want to know what that angle is. Okay, a couple of things that we need to know is, number one, this diameter, it's a radius, and a radius that goes to the diameter. This number one idea in orange is that a semicircle is equal to 180 degrees. We're going to use that later on. The second thing I need to know is a formula for circles. The question is, where is the vertex of an angle? So for example, angle R is on the circle. And if it's on, then you have this equation called angle equals the arc divided by 2. Let me show you how to use that. This angle QRS is 68 degrees. Angle QRS is equal to, we said 68 degrees. So arc divided by 2, arc divided by 2. Okay, so what is the arc that QRS is, the 68 degrees? Notice that it's from Q to S. So it's this whole arc here. I'm going to call this arc QPS. Arc QPS. And all I'm going to do there is just solve for it, and then I have one of my angles. So if I multiply this side by 2, I can multiply this side by 2. These will cancel, and then you're left with 2 times 68, which is 136 degrees, equals the measure of angle QPS. So, let's do this in blue here. QPS. That blue there has a arc measure of 136 degrees. Okay, what can we do next? Well, if I'm going to use this idea now, and I'm going to find arc QR. So a semicircle is equal to the major arc QPS and QR. So if a semicircle is 180 degrees, then angle QPS, which we found here in blue, is 136 degrees. If I subtract 136 here, I'll get the measure of angle arc QR is equal to 44 degrees. So this one in yellow, QR is 44 degrees. Okay, what I'm trying to do here is find the angle QPS. So QPS, you'll notice that the middle letter here is really what we're trying to find right here. What is this arc right here? And this arc, this angle intercepts Q and S. So it just essentially wants all of this. And then my next step is to add the yellow plus the semicircle. So step 4, I want to find angle QPS. The angle is equal to the arc divided by 2. And the arc, this whole arc here is 44 plus, let me write in letters, QR plus RS. I don't know what that is because I'm trying to find this. QR is yellow, so this will be 44. And then RS represents a semicircle, which is 180 degrees. So then angle QPS equals 224 degrees. And I forgot in my formula it's divided by 2, right? The whole arc. Let me try to color code that. So I'm trying to find this whole arc in pink. That's what the numerator is. So the equation is arc in pink divided by 2. So that would be 44 plus 180 divided by 2. So 224 divided by 2. Angle QPS is 112 degrees. And that is choice B. All right, question 15. Choose the order pair that is a solution to the equation represented by the graph. So a solution basically means that it's true. It's going to make anything true. Now, let's just make this super clear. Anything that's on the line is a solution that's made it true. Okay, so let's just teach you guys how to graph really quickly. The x-axis here goes left and right. And the y-axis goes up and down, and you do that second on the order pair. So up, down. Okay, so how do I graph this? 0, -3, I'm going to go 0 on the number line of x, and then -3, -2, -4, so -3 is between there. And this is not on the orange line, so not a solution, not solution. This would be false. 2 on the x-axis, 0 on the y-axis, that would stay right here. So again, that's not a solution, that's also false. 2, 2, so right 2, up 2, it's right there. That's not on the line. and negative 3, 0. Negative 3 on the x, which is between negative 2 and negative 4, and then 0 on the y-axis for me to stay. This one is on the line, which is a visual representation of all the answers. So the answer is D is your answer for number 15.
Hi guys, this is Mr. Halankar, and we're looking at the Smarter Balance practice question. And let's read the question. It says, consider the solution to a problem. And here is a problem. And there are 4 steps that follow. And the question is, it says, in the first response box, enter the number of steps where the mistake is made. Okay, so let's do that. So let's look at the question, let's go through the steps, and let's figure out where the mistake is made, right? So the problem is, it says negative 4, parentheses, 6 minus y plus 4 equals negative 4. Okay, now if I was to do this question, the first thing I would do is I would start distributing, right? I would start distributing. So if I'm distributing, it's going to be negative 4 times 6, that's negative 24. However, if you look at the next step, next thing that we do, negative 4 times negative y, that should have been a positive 4y, right? So right here, there's a mistake right there, right? So in step 1 itself, there is a mistake, which we're going to fix. But the answer to this question, at least, is step 1 is a place where there has been a mistake. That should have been a plus 4y, right? Now it says in the second response box, enter the correct solution to the problem. Okay, so we can actually do this question and step by step, and we'll figure out what the answer is. Okay, so let me write the question here. Okay, so I'm gonna start distributing. Okay, so negative 4 times 6 is negative 24. Negative 4 times negative y is positive 4y plus 4 equals negative 4. Remember, we're solving for y, so you want to isolate this variable. You want to have that by itself. So I'm going to add like terms. Negative 24 plus 4 is negative 20. So I'm adding like terms. These are like terms I'm adding. Okay. I'm going to add 20 to both sides. So let me add 20 to both sides. Okay, we're almost done. Okay, so 20 minus 4 is 16, right? And to finish this, I just have to divide both sides by 4. So our answer should have been a 4 rather than a negative 4. So this is a correct answer. Hi students, this is question 17. This is question 17, and we're about to solve this question. So let's read it. It says, consider a sequence whose 5 terms are negative 1.75, negative 0.5, 0.75, 2, and 3.25. Now, this sequence, if you look at it and kind of analyze it, you'll quickly find out that this is an arithmetic sequence. And the reason this is an arithmetic sequence is because you go from first term to the next term, you're adding 1.25 each time. You're adding 1.25, right? And we know that whenever we add a same term or same number each time, that sequence is an arithmetic sequence. Now the question says, which of these functions below could be used to define and continue this sequence? So we're basically looking for a function that represents this sequence. All right. So I know that whenever we work with the arithmetic sequence, here's something we use when we work with arithmetic sequence. And you probably have seen this equation before. So it goes like this: an equals a1 plus n minus 1 times d. Okay, and I'll explain what the terms in here are. Okay, so a1 is the first term in our sequence, Okay, and D is the difference between each of the consecutive terms, right? So let's plug that into this formula or this equation and let's see what we get. All right, so we have an equal a1 is negative 1.75 plus n minus 1 times d, or difference we just figured out, or difference is 1.25, right? 1.25. Now if you look at our answer and if you look at the answers which are given, you know, the answers which are given are not in decimal, they are in a fraction form, but that's okay because I think we can figure out what's going on. All right, so let's see. An equal, okay, now I'm gonna go here and I'm looking at this decimal 1.25. okay, now 1.25 is bigger than 1, right? So you know, if you want to go from a decimal to fraction, what we can do is I can go 1.25 is same as 125 divided by 100. Okay, and if I come here, 1.75 is same thing as 175 divided by 100. All right, now we still don't have a very similar answer, but we're getting there. Now all I have to do now is kind of reduce as much as I can. All right, so let me reduce. Let's see if we can reduce as much as we can. All right, we can reduce this by 25. So we know 25 goes into 100 4 times and 25 goes into 125 times. So this is 5 over 4. So 1.25 is 5 over 4. And 25 goes into 100 4 times here. And 25 goes into 175 7 times. Okay, so you get negative 7 over 4, and that represents negative 1.75. Now it's coming together, right? Now we're kind of seeing where the answer is. So let's see, I'm going to rearrange a couple of things here. Okay, all I'm doing is just rearranging it. So I'm writing 5 over 4 first, and then n minus 1, and then minus 7 over 4. Remember, this is a commutative property, so I could do that. So here is the final answer. So let's see where it is. It's right here, B. And that's the answer. All right. Okay, guys, this is question 18 on SBAC review, and we're trying to answer this question. So let's read the question. It says, write an expression equivalent to B11 divided by B4, or B11 or B4 in the form of Bm. Okay, so we're trying to simplify this fraction, or this expression we're trying to simplify. Now we know a couple of things about dividing exponent. Okay, we know that whenever you divide exponent, you subtract them. So in order to get this question, all we have to do is just go B11 minus 4, right? So we're going to subtract them. 11 minus 4 is B7. So right here, that's the answer. Now this is a quick way of thinking about this question. Now I could have done this the long way too, right? B11 means I have to write B11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 divided by B4. So that's 4 times. 1, 2, 3, 4. Okay, and if I reduce them, right, and if you figure out how many B's are left, you know, you can count them 1, 2, 3, 4, 5, 6, 7, and therefore the answer is B7. So, but this is the fastest way of simplifying any fraction that have exponent in it and you're trying to simplify. You know, the best way to go about doing this is when you're trying to reduce, you subtract the exponent. So you just go 11 minus 4 is 7. So the answer is B7. All right, guys. Good morning, students. This is question number 19 on SBAC practice, and we're trying to answer this question. So let's read the question. It says, Nina has some money saved for a vacation she has planned. The vacation will cost total of $1,600. She will put 150 every week into her account to help pay for the vacation. She will have enough money for the vacation in 8 weeks. Okay, if Nina was able to save $200 a week instead of 150 a week, how many fewer weeks would it take her to save enough money for the vacation? Enter the result in response box. Okay, so let's take first situation. She's able to save $150 every week, and the vacation is costing her $1,600, right? So if she saves $150 every week, how many weeks is it going to take to reach $1,600? So let's figure that out. So I know that, if I take $150, and if I multiply that by 10 weeks, right, just 10 weeks, in 10 weeks, how much money will she have, right? So 150 times 10 is $1,500. Now you can clearly see that she's still short of the money that she needs. Okay, so maybe she has to go maybe half a more week. So, but at least on minimum, she needs, more than 10 weeks to save for her vacation. All right. Now let's see what happens if she starts saving $200 per week. How many weeks does she need to get to 1,600? Now 200. Now I know that 200 times 8 weeks. I just need 8 weeks. Like 200 times 8 will help her reach her goal of $1,600. So you can clearly see that it takes her 2 less week. If she saves $200 per week rather than 150, it will save her 2 weeks, at least 2 weeks, to get to the total she needs. So the answer to this question is 2 weeks. Hi guys, let's look at question 20 on the Smarter Balance practice exam, and let's see if we can do this one. So, okay, it says, let's read it. It says, consider a parallelogram ABCD with point X at the intersection of diagonal segment AC and BD. So these are the intersection of this parallelogram. Now here's the second sentence. It says, Evelyn claims that ABCD is a square. Select all statements that must be true for Evelyn's claim to be true. Okay, so Evelyn is claiming that this is a square, and we have to select all statements which are true. Okay. Let me zoom out. So which of these statements are all true? All right. So let's go over them and let's see if we can answer them. Okay. Remember, her claim is that ABCD is a square. Okay, now a couple of things we know about square is that all sides are equal for square, right? So here, AB is equal to BD. AB is equal to BD, right? Now that's not necessarily true for the square. AB is not equal to AD, right? It's not. So let's go to the second statement. It says AD is equal to AB. So AD is equal to AB. Yeah, and we know from definition of square that, yeah, these two sides have to be equal. So this statement is true. So I'm going to mark it true. Okay, next statement, it says AC has to equal to BX. So AC has to equal to BX. And you can see obviously that is not a true statement. AC is not equal to BX. Okay, so that's not a true statement. Let's go to the next one. It says measure of angle ABC is not equal to 90. So measure of angle ABC, this angle is not equal to 90. And you can in fact see that it has to be 90 because the angles inside the square are 90-degree angles, right? These corners meet, they are perpendicular, so they meet at 90 degrees, so they have to be. So this is not a true statement. Now let's go to the next one. It says measure of angle AXB is 90. So measure of angle AXB, this angle right here, is 90. And we know from the definition of square is that the diagonal inside the square are perpendicular, so that angle has to be 90. They do intersect at 90 degrees. So measure of angle AXB has to be 90. So these are the only two statements which are true for Evelyn's claim. If Evelyn claims that it's a square, these two statements are a true statement. Okay. All right, guys, let's look at this next question. Question 21. And let's read it and let's see what it says. It says, a student earns $7.50 per hour for her part-time job. She wants to earn at least $200. So she's earning $7.50 per hour and she wants to earn at least $200. Okay. Now the first question or direction, it says enter an inequality. Okay, so I gotta enter in inequality that represents all the possible number of hours the student could work to meet her goal. So you want to enter an inequality for this student so she can meet her goal. All right, so we know that in order to meet her goal of earning $200, what we need to do is we need to get $7.50 she's earning per hour. Okay, multiply that by number of hours she's working, right? And that has to be greater than or equal to, because it says at least $200. So $7.50 times number of hour this student works has to be greater than or equal to $200, right? This is an inequality that represents this first sentence. All right. Now for the second one, it says enter at least a whole number of hours the student needs to work in order to earn at least $200. So how many numbers of hours, whole number of hours the student needs to work to earn at least $200. Okay, so we're solving for hours, we're solving for age. So what we need to do, okay, I'm going to show work here, but what we need to do is divide both sides of this inequality by 750. All right, and if we get the answer, if we use our calculator, you approximately get 200 divided by 750. It's 26.66 hours, right? So student needs to work more than or equal to 26.66 hours to earn at least $200. But again, remember, the question is asking you to enter whole number of hours. So if we round this up, the whole number of hours that she needs to work is 27 hours.
All right, this is question number 22. Michael took 12 tests in his math class. Here's my 12 tests. His lowest test score was 78. So I'm going to put these from least to greatest. So I'm going to put 78 right there. His highest test score was 98. So the 12th test, 98. On the 13th test, he scored a 64. So I don't have a number line, but like way, so I can fit something way over here. Select whether the value of each statistic for his test scores increased, decreased, or cannot be determined when the last test was added. Let me go over these really quickly. Standard deviations called measures of spread. What that means is if you have a piece of toast and you put some peanut butter or jelly on there and you spread it with a knife, greater the spread means it's spread out, the data spread out. Median means middle. And just think about a road. Here at Savannah, you might going from school and then you're trying to go to the golf course, get some french fries, and then you might stop in the middle of the road because a bunch of traffic's going there. So this is called the median. It's the middle. And then the mean is the average. You add up the sum and then divide it by the total number of values. Okay, so the question is, 64 is kind of like a number far stretched out here. That seems like an outlier, and it's pulling the center away. And if it's pulling the center away, the one that it's most sensitive to outliers is actually the standard deviation. So this one's going to move a lot. And the standard deviation, you'll see it's going to increase, the number will increase. The median now, if you think about it, let's just say this is the 13th number. You have 13 numbers, so I'm going to count 6 numbers. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So there's 6 to the right, 6 to the left. This 6th test is the median. We don't know what value that is. But I'm going to pick the number 88. And that'll make it kind of clear once I use a calculator. Now, without the 13th test score, if it was just these 12 numbers, it would be 6, right? So it's an even number, so it would actually be between the average of the 6th and 7th number. So you would add these two numbers and divide by 2, and it's actually 88, so it doesn't change. So the median doesn't change based on that outlier. And then the average, although the outlier is to the far left, it's pulling that number. It's not really pulling it a lot, okay? So let me prove this to you numerically, and it's just easiest if you have a graphing calculator. Battery's low. Let's try my other calculator. And some Texas Instruments and Casios can actually put in one variable stats. So I'm gonna go to my home screen here, and I'll do my best to tell you all the calculator commands I'm pressing. So I need to get to a list, so I'm gonna have to press second stats. So second stats, and then you have your list here. Those are the names of the list. Actually, you don't need that. So you press stat, and then you press edit. So you can press 1 or enter, and there I have the numbers. So I'm going to go ahead and just input all these numbers, 78, and then enter. And then the reason why I chose 88, because I think just pressing 88 is fast, and it's a number between 78 and 88. And it's actually telling you which test number it is as you're putting it in, right? That's the 10th test, 11th test, and then 12th test we said would be 98. Okay, so let me make a table. Okay, so I call this the original 12 tests. And we have the standard deviation. We have the median. And we have the mean. Okay, my calculator commands here. Now that I have that number in there, this is just the first 12 numbers, right? Because the 12th test is 98. And then I'm going to press stat, move over to calc, so press right. And then I just want one var stat, so you can press enter. That pops up on your calculator. If you have a newer TI-84CE, it'll say like frequency, just keep pressing enter, enter, enter to calculate. Okay. X bar is your mean. So that'll be 88. The average is 88. This is summation of all the numbers. So if you added all the test scores from 1 to 12, that would be 1056. If you took this list and just squared it, you would get this number. This is the sample population. And this is the population standard deviation. So sample standard deviation, population standard deviation, that one's just divided by n-1. And you press down, you have 12 tests to verify. Here is your 5-number summary. The lowest number is 78. First quartile, we don't really need that, 25%. Here I need that one. Median is 88. And then the standard deviation that I wanted was, since you know all of the numbers, you can do, you can just put both, doesn't really matter, and you'll see what happens. And I'll just round because we just want to see if the numbers are going up, down, or staying. Okay, so those are the original 12 numbers. And then you press Stat, and then Edit, press 1 or Enter. And then I'm just going to go to the bottom of my list and go down to the 13th test. Oops. And then Michael. There it is. This should be blank. And then you're just going to type in 64. You're going to press Stat right here. Calculate, so move over one of our stats, press Enter or 1. Okay, you're going to do it again. And now these are the 13 numbers. And then you just compare your numbers. The average, there's my standard deviations, and then go down and you press median would be 88. All right, so let's compare these numbers. Let's start with standard deviation. I look at these numbers and I recognize that the numbers do what? They increase. So going from here to here, they're going up. Here the numbers stay. And then the number here to here, from the 12 and then 13 test, it decreases. So the answer for the standard deviation is that it increases. The median stays. Guess you could put cannot be determined, or it's not increasing, not decreasing, so this would be your best option. And then the average decreased. And then those are your answers for question number 22.
Hi guys, this is question 23 on the Smarter Balance practice exam, and let's try it. Okay, let's read. So it says Emma is standing 10 feet away from the base of a tree and tries to measure the angle of elevation to the top. She's unable to get an accurate measurement, but determines that the angle of elevation is between 55 degrees and 75 degrees. Decide whether each value given in the table is a reasonable estimate for the tree height. Select the reasonable or not reasonable for each height. Okay, so these are the answers given, and we just have to select which one is a reasonable answer and which one is not. All right, so as I'm reading this question, I'm thinking about trig functions, and we have to use one of the trig functions. So, but what I like to do is with these type of question is, it's always a good idea to draw the question out. So I'm going to draw the question out, and here's the question. So Emma is standing 10 feet away from the tree, so I'll draw a tree. Okay, here is a tree, and let's say Emma is standing 10 feet away from the tree, so maybe right here. Okay, and she takes angle of elevation to the top of the tree, so she'll take angle of elevation to the top of the tree. Remember, angle of elevation starts horizontally and you're just looking up, right? Okay, now she's not sure what this measurement is, but she's thinking this is either it's between 55 and 75 degrees. It's between 55 and 75 degrees, and if it is 55 and 75 degrees, then what is a reasonable answer for the height of the tree? Okay, so we're looking for this opposite side, height of the tree. So it's opposite of that angle. So what I'm thinking of is using trig function, and in this case I'm going to use tangent, because the unknown side is the opposite, known side is the adjacent side to that angle. So I'm thinking about trying to do this question using a tangent. So I'm going to set it up using a tangent. So I'm going to go tangent theta equal opposite, which is 8h, divided by adjacent 10, right? Now, Emma doesn't know what that angle is, but she thinks it's between 55 and 75. So I'm going to try both out. So I'm going to try the lowest end of her guess, which is 55, and I'll try 75, and let's see what comes out. So I'm going to go tangent of 55 degrees equal h over 10. Okay. Now, if all I have to do to find the height of this tree, if it was 55 degrees, is multiply both sides by 10. And if you plug this in your calculator, 10 times tangent 55, you will get approximately 14.28 feet as an answer. So this is a lower end of our answer. So this tree is at least 14.28 feet high. Okay, and then, now let's see what's the other end of the answer. So same exact thing, same function. But this time I'm going to use 75 degree, the higher limit on the angle. So tangent 75, what if it was 75 degree? What would be the height of the tree? So tangent 75 equal h over 10. I'm going to multiply both sides by 10. Okay. And if you plug this in your calculator, 10 times tangent 75, you get approximately 37.32 feet. So here is the lower end of our answer, and here is the upper end of our answer. And now if we compare that to the answers which are given to us, now we can correctly make out which is a reasonable answer, which is not a reasonable answer. So this tree, the height of this tree could be between 14.28 to 37.32 feet, right? So this first one is not reasonable. Okay, this is reasonable. This is reasonable. This is reasonable. Okay, the highest was 37.32. This is not reasonable. This is over, right? So this is not reasonable. This is not reasonable. All right. So you can see, like, whenever you see a trick question or word problem, I think it's a good idea to draw a basic picture of it and maybe set up the equation, and you can solve it.
All right, guys. Let's look at this question. This is question 24 on the Smarter Balance practice exam, and let's see if we can do this one. All right, so let's read it. It says, Emily has a gift certificate for $10 to use at an online store. She can purchase songs for $1 each, an episode of TV shows for $3 each. She wants to spend exactly $10. Okay, now let's see what part A says. Part A says, create an equation to show the relationship between the number of songs X Emily can purchase and the number of episode of TV show Y she can purchase. Okay, so in part A here, in this first box, we want to create an equation that shows number of songs she can purchase and number of TV shows she can purchase if she has only $10 to spend, right? So we're gonna write that equation. So we know that for each song she has to pay $1. So we're gonna multiply the variable x by 1. So it's gonna be 1x. Okay, and then we're gonna multiply the variable y, which represents the number of TV shows, by $3, right? Because that's how much they cost. Okay, and altogether she has $10 to spend. So that's it. That's part A. So 1x plus 3y equals 10. That's the equation that represents the relationship between number of songs and number of TV shows Emily can purchase. Right? Okay, now let's look at part B. It says, use the add point tool to plot all the possible combination of songs and TV shows Emily can purchase. So here what we're looking for is the whole number of songs and whole number of TV shows Emily can purchase and spend $10 for it. Okay, so for example, if Emily purchases 10 songs and 0 TV episodes, she'll spend $10, exactly $10. So that's our first point on the graph, 10 and 0, 10 and 0. So here is 10, 0. Right? So she can purchase 10 songs but 0 TV shows. Right? Another one I can think of is she can purchase 7 songs. So that would cost her $7, right? 7 times 1 is 7. And maybe 1 TV show, that would be $3, right? So 7 plus 3 again would be 10. 7, right? So another combination we have is she can purchase 7 songs and 1 TV episode. So that's our second, that could be our point. So 7, 1. Okay. Another one I can think of is maybe she can purchase 4 songs, so that would be $4. Okay. She'll have $6 to spend, so she can purchase 2 TV shows, so $4 for songs and $6 for TV shows, and she'll be able to spend $10. So that's our next point, 4, 2, 4, maybe 4, 2, right? Another point I'm thinking of is, how about she only purchased 1 song, so that's $1, and 3 TV shows. Okay, so 3 times 3 is 9, so $9 she's spending for TV shows plus $1 for songs, so that would add up to 10. So that's our next point. We can have 1, 3, 1. Okay, and those are the combination of movies and song Emily can purchase, and at the same time she'll spend $10 for them. Alright. Okay guys, so yeah, let's look at this example from Smarter Balance practice exam. This is question number 25. Okay, and let's see what it's asking us to do. It says, consider this right triangle. So we're given a right triangle, and we're given 2 of the sides. We're given this side, 21, side TS, and then we're given hypotenuse, which is 35. Okay, and let's see what it's asking us. Okay, so it says, determine whether each expression can be used to find the length of the side RS. Okay, so let me kind of mark that side. So we want to find out this side, RS. And what the question is asking you is if any of these expression could be used to find that side RS. Okay, all right, so let's look at the first expression. It says 35 times sine R. Does 35 times sine of angle R, does that give us side RS? So let's think about it. Okay, so the definition of sine is opposite over hypotenuse. That's the definition of the sine function. So sine of any angle is a ratio of opposite side divided by hypotenuse. So if I use this function, do I get that as a valid statement? We'll figure it out. So the statement has an angle R in it, and if I write this sine in terms of angle R, let's see what we get. Okay, so I'm going to go sine R, and here is angle R. Okay, opposite of that angle is 21, and hypotenuse, you can see, is 35. Okay, And if I multiply both sides by 35, I do get a statement that says 35 times sine r. However, it's not equal to side rs. It's actually equal to side ts, right? Which is 21. So this first statement or first expression, no, it doesn't. We cannot use that to find side of rs. So I'm going to check no for that one. Okay. Now let's look at the next statement. It says 21 times tangent t. Now, definition of tangent is opposite or adjacent. And let's work this one out, and let's see if it's a valid statement. So it says tangent t. So I'm going to set the equation up for tangent t. So I'm going to go tangent t equal opposite side of tangent t is rs. Okay. And that's good to have because that's what we're really looking for. Divided by adjacent side, which is 21. Okay. And if I multiply both sides by 21, okay, we do get a statement that says 21 tangent t equal length of rs, which we're looking for. So yeah, this second statement, yes, we could use it to find the length of rs. Okay, we got two more to go, so let's look at the next two. Next one says 35 cosine r. So this is a definition of cosine. Cosine is adjacent or hypotenuse. Okay, it says cosine r. So I'm going to write this in terms of r. So I'm going to go cosine r equal adjacent side to r. Adjacent side to r is side rs. Okay, that's good to have. Okay, and hypotenuse is 35. Okay, if I multiply both sides by 35, you do get a through statement. You get 35 times cosine r equal the length of rs. So it is a right statement. It does give you a way of finding the length of rs. So yes for this one. And we got one more statement to check. It says 21 tangent r. So I'm going to set that up. So I'm going to go tangent r equal, we know definition of tangent. Tangent is opposite or adjacent. Opposite or adjacent. So tangent is r is 21 divided by length of rs. Alright. And if I try to simplify this a little bit, I don't get a through statement that we're looking for. We get a length of rs times tangent r should give us 21, not 21 times tangent r equals rs. So this statement is a false statement. It doesn't give us the side we're looking for, so we're just going to mark it no for that one.
Good morning, guys. This is question 26 on the SBAC practice exam, and here's what the question is asking us to do. It says, given the function y equals 3x squared minus 12x plus 9, it says place a point on the coordinate grid to show each x-intercept of the function. Okay, so we want to find x-intercept of the function. So you can see what I have done is I have let y be 0. So because we know x-intercept occurs when y is 0, so I'm letting y be 0. So I'm taking the equation and I'm setting y equals 0. Now if we solve this, then we'll get the x-intercept. So let's see. So we can solve this by factoring. So I'm thinking about factoring 3 out. Okay. Alright, so it looks easy enough for us to kind of work this one out. I can factor more. I can factor using guess and check or the x method. So we need two numbers that multiply up to 3, add up to -4. So two numbers are -3 and -1. They add up to 3 and they add up to -4, and multiply to positive 3. Okay, so almost done. So I'm going to take each factor, set it equal to 0. We should get our x-intercept. Here is one x-intercept, and let's see where the other x-intercept is. Here is the other x-intercept. So these are the two x-intercept for our function. So let me plot them. So one is at 3, one is at 1. These are the two x-intercept. Now second question says, it says place a point on the coordinate grid to show the minimum value of the function. So we want to show where is the minimum value of the function. Now this is a parabola that opens upward. It's a parabola that opens upward. So we know minimum value occurs where the vertex of this parabola is, right? So now we know that these are the x-intercepts. So the vertex of this parabola occurs right in the middle of these two x-intercepts, which is at 2. So we know that the vertex occurs, let me write that. So vertex occurs at 2, and now all we need to do is just figure out the y value of the 2, right? So I'm going to take 2 and plug it back into the equation, and that would give me y value of our vertex. So let's see.
Because we go from 900 to 9. Oh, David, do you have zip grade?
No.
No. Okay.
We got the scanning and then the multiple choice.
Yes.
Nilesh, can we put this in our district fund?
So our y value is negative 3. So our vertex is 2, negative 3. So 2, negative.
David, how much does this, like, how much background noise does the recordings pick up?
2, negative 3. So right there, that's your answer. So you find x-intercept by setting y equals 0. You factor, okay, you get your x-intercept. Vertex is located right in the middle, right? That's 2. And you take 2, plug it back into the equation right here, and you got the y value of your vertex, which is 2, negative 3. All right? Thank you. Okay, guys, let's do this question on the SBAC practice exam. This is question 27. Okay, and let's see what it says. It says Mike earns $6.50 per hour plus 4%, I'm guessing 4% commission of his sale. So he earns $6.50 time number of hours he works plus 4% of his sale. Okay, so it says enter an equation for Mike's total earning. So Mike's total earning is given by capital E when he works X hours. So hours are represented by variable X and has a total of Y sales. So Y sales are represented Y. So we just had to create a straightforward equation that would show Mike's total earning. All right, so we could do that. So we're going to go Mike's total earning, E equal, we're going to go $6.50, right, times number of hours he has worked or number of hours he's planning to work, which is represented by X, okay, plus, okay, 4% of his commission. So 4%, we have to make sure that we write 4% in decimal. So 4% in decimal, we can easily convert that. We can go 4% is same as 4 over 100, which is 0.04. So that's 4% in decimal. So we go $6.50 times number of hours he works plus 0.04. His how much he gets from his commission, how much he gets from his sales. So 0.04 of his sale. So 0.04 times how much his sale, which is given by letter Y. Okay, so right there, that's the equation that represents Mike's total earnings. $6.50 times number of hours he works and 0.04 times his total sale.
Okay guys, hi everyone. We're gonna work on question number 28 on the Smarter Balance practice exam. So let's read the question. It says the basketball team sold t-shirt and hats as a fundraiser. They sold a total of 23 items and made a profit of $246. They made profit of $10 for every t-shirt they sold and $12 for every hat they sold. And the question is asking us to determine the number of t-shirts and the number of hats the basketball team sold. Alright, so looking at this question needs for us to solve systems of equation. So first of all, we have to come up with systems of equation, and then we can go ahead and solve it, right? So I'm gonna underline a couple of important numbers here. So first number that I'm just gonna underline is 23. That's how many items were sold. So we can come up with the equation for that. Okay, so let's say let's call number of hat H, and let's call number of t-shirt T, and H plus T then will be equal to 23 because 23 items were sold, right? So we get our first equation in the systems of equation just by going H plus T equals 23. Right? Now the second equation is going to be about the profit, right? The team made $246 as a profit, and they made that by selling t-shirt for $10 each and hat for $12 each. So we can come up with the equation using that information. So I'm going to go $12 times number of hats sold plus $10 times number of t-shirt sold, and all together the team made $246 profit. Alright, so here we have systems of equation. We have two equations, we have two unknowns, and we're trying to solve for both of these unknowns, right? Well, we can solve this one of the two ways. We can solve this using substitution method or elimination method. And looking at how the question is set up, I feel like elimination method is a best choice. So in elimination method, what you do is you try to get rid of one of the variable. In this example, either hat or t-shirts, and then you'll be able to solve this question. So I'm thinking of looking at the numbers. I'm thinking of canceling T for t-shirt. I'm trying to get rid of T. Okay. Now, if you look at the second equation, it's 10T. So if I can just get a negative 10 in the first equation, negative 10T, I'll be able to cancel that, right? So I could do that. We can find that by multiplying both side of the first equation by negative 10. I'm going to multiply both sides by negative 10, right? And let's see what happens. Let's go. Okay. Now I'm going to keep going. So if I distribute, I get negative 10H, negative 10T equals negative 230, right? The second equation, we don't have to do anything with that one, so it stays as it is. So that's going to be 246. Right? Just by multiplying both sides by negative 10, now you can see that we're able to cancel the variable t. So that's gone. So negative 10h plus 12h, that's going to be 2h equal negative 230 and 246, that's 16. Right? And then all we have to do now is just divide both sides by 2. Okay, so number of hats sold, or H in our example, is going to be 16 divided by 2, which is 8. Okay, so number of hats are 8, but we're not done though. We still need to find out number of t-shirts sold, right? So we're almost there. So you're going to take 8, the number of hats sold is 8, or you're going to take that answer, use that to find number of t-shirts sold. So we're going to take 8, plug it back into any one of these two starting equation, and you'll be able to solve for number of t-shirts sold. So I'm going to plug it into the first equation. It looks easier. So I'm going to plug it into the first equation here. So I'm plugging in 8 for hats and To get t-shirts, we just subtract 8 from both sides, and you get 23 minus 8, which is going to be 15. So here's the answer. So number of hats sold are 8 and number of t-shirts sold are 15. And that's the answer.
Hello, man.